morning, students. Welcome into the another session of CS22 operating system concepts using Linux and Unix. As all of you know that we are discussing about the concepts of process management. Many technical aspects we have already discussed, that what is process, different types of process state diagram, and internal components of process state diagram like scheduling queue, program counter, types of schedulers, etc. etc. Now, all these are the theoretical part that we have discussed. All these theories are depend on some algorithms. That is the topic of discussion that we are going to do now. So the title of the topic is process scheduling algorithm. Even in this topic, there is a periodical development into the various algorithms. As you can see onto the screen, there are various types of process scheduling algorithms are available in our subject, like FCFS, called first come first serve, SJN, that is called as shortest job next. Next is priority scheduling, shortest remaining time, round robin scheduling, multi-level queue scheduling. So all these are the different types of algorithm that we have to discuss. So let's start with the first one, that is first come first serve. Now, into the first come first serve, first we need to clear that algorithm theoretically, then we can go ahead for the another one. As the name is suggested, in this algorithm, it just like the concept of queue that we have discussed in data structure. That means in this algorithm, whatever the job are created by the central processing unit, here the job are the various types of process. That means the various types of process which has been created for the by the central processing unit will execute in first come first serve basis. That means whichever the process created first by the central processing unit, this algorithm will execute that process first. We know that process are of three different types, that is mini process, major process, and the microprocess, where the life cycle of microprocess is very short. The life cycle of mini process is little bit high, and major process continues till the system is on. So this particular algorithm will not look after which type of process is, either it may be mini, micro, major, whatever. This algorithm executes that particular process at the first execution. Due to this particular algorithm is called as primitive algorithm type. This algorithm is easy to understand and implement. The entire scenario in this particular algorithm will be based on first in first out queue. Now due to this, the execution and the performance of this particular algorithm is poor, and the waiting time for executing the next process is very high. That means, suppose our operating system is using first come first serve, and the first process is a minor process and second is a major process, then that major process have to wait till the minor process gets completed by the central processing unit. So we can say that the average waiting time in first come first serve algorithm is very high, and due to this the overall performance of first come first serve is very poor. On right hand side you can see a one diagram, or you can say that one table, in which I have mentioned three processes with their arrival time and the execution time. By comparing the arrival time and execution time with each other, the service time is mentioned over here, where you can see that the process number 3 waits till process number 2, process number 1 and process number 0 gets completed. As the service time is higher than the all previous one, it is considered to be a major process. As though it is a major process, till P3 have to wait for P0, P1 and P2 gets completed by the central processing unit. Once the confirmation came from central processing unit that all the resources which has been occupied by the previous processes, that is P0, P1 and P2, then and then central processing unit will accept the process number 3. So this is one of the disadvantage of first come first serve algorithm. This is removed into the development of algorithm by introducing the newer concept called shortest job next. This is actually the implementation of an algorithm by considering the disadvantage of first come first serve algorithm. In short, shortest job next is also called as SJN. Now, this shortest job next algorithm executes all the minor process first, and then it queue up all the shortest job next first execute all the micro process first, and then queue up all the minor process, and then it queue up all the major processes. That means in this particular algorithm there is a concept of batch. It means it creates the batch for all micro process first, that is unit number 1, or you can say the section number 1, or we can say a division which contains only all the microprocesses. Then it contains the another division section batch that is called as minor processes, and finally it contains the third batch section division which is called as major processes. Now the role of this particular algorithm is to decide which process is going to reside in which section. See, our machine is a hardware. It doesn't contain a brain, that is no self-disciplinary manner into the central processing unit. Everything is planned and instruction is passed by the central processing unit. According to that, the all hardware will work. So central processing unit decides this process or the number of process comes into the first block called microprocess. Rest of the comes in minor process, that is group number 2, and all other remaining comes into the group number 3 called major process. So once all this allocation is done by the central processing unit, then one by one, depending on to the priorities, it will execute the number of batch itself, where in first concept called first come first serve, individual processes get executed by central processing unit, while in shortest job next, entire bunch, group, batch, division, whatever the word we use, executes at the same time. So this is the benefit of using shortest job next. Now due to this theoretical concept, it gives all of us a one advantage, that is, it is best in approach to minimize the waiting time for the microprocess or even for the major process and obviously for the microprocesses. This particular concept is easy to implement in batch system where required central processing is known in advance. Yes, we can say that the responsibility of a central processing unit get increased if our operating system use shortest job next. That means our central processing unit works like a multitasking hardware where CPU have to generate the process, even they have to allocate the number of process into the proper block so that the batch of entire processes get executed at the same time. So for that, CPU should previously know that which process is going to be stored in a relevant sections. Now, in this particular algorithm, it is impossible to implement interactive system where the CPU time is not known. What it try to say is that in operating system, in a fraction of time, number of processes get generated by the various resources. Obviously, these are called as requests. Some of the requests are known and some of the requests might be unknown. That means the proper resource allocation has not been done by the central processing unit. That means till the relevant resource allocation is not done by the CPU for the request which has been generated by the various resources, or you can say the user, it is unknown. And if the process is unknown, then the execution time is also unknown. For that type of process or the bunch of process, this particular algorithm will not work. This is one of the major disadvantage of shortest job text. Now, for the known processes, that means the group of process which is known by the CPU, known by the resources, known by the users, known by allocating the resources, for all that processes, the CPU should know in advance how much time processor will take to execute that bunch. One calculation is given over here where I have mentioned the three processes. The formula that we have applied for all this calculation is process is equals to service time minus the arrival time. Instead of the word called process, we can also use the word called waiting time. So even the formula can be written like waiting time is equals to service time minus arrival time. So three processes yet I have mentioned over here, which might be millions of or hundreds or the thousands of processes are there. P0 is equals to 3 minus 0, where 3 is the service time and 0 is the arrival time. By deducting 3 minus 0, there is a calculation of waiting time is over there. Same is followed for P1, P2 and P3. Here the figure is not concerned for the discussion of the entire topic. The thing is that from these three services, that is P0, P1, P2 and P3, total 4 services, the less waiting time for the process is P1, that is 0. So CPU decides this P1 process requires a very less time to get executed into the entire system environment. So central processing unit will give the priority to the shortest job, that is called as P1, and it executes the same into the system. Then it goes for P0 as its waiting time is 3, that is the shortest job is 3. The first shortest job is 0, then shortest job is 3, or you can say the shortest job is P1, then P0, then P3, and lastly it executes P2. So from the entire batch of P0 to P3, central processing units executes P1 as a microprocess, P0 and P3 as a minor process, and P2 as a major process. Once this entire batch completes, it generates the another batch for the another processes. Till that all the resources should have to wait to get free resources or free resources allocation by central processing unit. Let's move on. The disadvantage of first come first serve and shortest job next is going to be removed in another algorithm that is called as priority based scheduling algorithm. And right now in almost all operating system, this particular concept is used, that is priority based scheduling. What does it means? It means that priority scheduling is a non-primitive algorithm and one of the most common scheduling algorithm into the batch system. Our current operating system obviously use the concept of batch operating system. No doubt that concept is older concept into the operating system, but still it is considered into the development of newly designed operating system. Again I am repeating my words. Priority based scheduling algorithm is a primitive algorithm and one of the most common scheduling algorithm which is used in batch system, where each process is assigned a priority process with high priority is to be get executed first and so on. That means in this particular concept, each and every batch which is designed by the central processing unit, say for example 5 batches, 5 process are there. It's just an example. So total there are 25 processes. From all that 25 processes, or we can say the batch of 5, CPU decides which are the minor processes in all the batch. It might possible that in every batch there is a microprocess, minor process, and even the major process. But this particular scheduling algorithm first take all the microprocesses from all the batch. It fetch all these processes from all the batch. That means it fetch all the microprocesses from all the batch and creates a one queue of only the microprocesses, mini processes, and then rest of the processes will store as a major processes. And then it executes that particular block. The benefit of using priority based scheduling is that from all the batch, it finds out the microprocess stored as a separate block, and then it executes that block on priority base. So overall performance of the central processing unit get increased by using this particular concept. Let's move on. Process with the same priority are executed on first come first serve basis. Priority can be decided based on memory requirement, time requirement, and other resources requirement. Obviously, all the microprocesses required a very less resource allocation. If we combine all the microprocesses, it might be considered as a one minor process also. That means the total number of resource allocation is higher than the single resource allocation which is done by microprocess. If central processing unit executes that particular batch first, then the resource allocation which is done by the CPU individually for all the processes get released within a very short interval. So this is the benefit of using priority based scheduling. The same thing is mentioned over here in one table where there are total 4 processes are there. They calculates the number of waiting time by deducting service time with arrival time, where you can see that process number 3 is a waiting time called 0. Then the highest one is P1, which contains the waiting time called 5. Then again the highest process number 0, which contains the waiting time 9. And the last process number 2, which contains the waiting time called 12, is going to be executed. Here the 0, 5, then 9, and lastly 12 were fetched from various batch which has been generated by the central processing unit. The next discussion is shortest remaining time, which is also called as SRT. Shortest remaining time is a primitive version of shortest job next. Always remember that whenever the newer concept get introduced into the market is due to the lack of previously searched concept. So this shortest remaining time is introduced into the market due to the lack of shortest job next. In this particular algorithm, the processor is allocated to the job closest to the completion, but it can be preempted by newer ready job with shortest time to complete. This is little bit trickier, or we can say that it is not easy to digest. Generally, what happens during the execution of the processes, remember one thing: the creation of the process and the termination of the process is continuous or in a loop till the system is on. Now, what happens during this loop? Say for example, the central processing unit has created the number of batch which contains the group of micro mini major processes. As the central processing is about to finish all this requests, and suddenly user has requested something changed, which changed the scenario of resource allocation which has been done by central processing unit, which might disturb all the batches which has been created by CPU. That topic we have not discussed up till this discussion, but it might happen. So to handle this situation, researchers, or we can say the technocrats, find out the technique called shortest remaining time and implemented the same. Let me again clear the concept. What is the purpose of shortest remaining time? The purpose of shortest remaining time is to look after the number of process which has been generated and executed by the CPU in various batch, whether that particular process is near to the time which is defined by the CPU for the process which is already executed in a queue. In short, from the bunch of process, CPU has already decided this process contains a very less time. But during the execution, if CPU finds some process which is near to that particular time of execution, which is the shortest one, it allocates that process on a very next sequence. That is called as shortest remaining time. Now in this algorithm, it is it is impossible to implement in interactive system where the required CPU is not known. Something or similar like shortest job next. It is often used in batch environment where the short job need to give the preference. In our next lecture, we will go for the another scheduling algorithm, which might be the last one, sorry, the last, second last one to be discussed in unit number 2. Two scheduling algorithms are remaining, that is, one is round robin and multi-level queue scheduling. We'll discuss in next lecture. Thank you very much students for listening me, and have a nice day.